let's introduce radians. Now, to begin with radians, we should start with this pretty simple fact. How they discovered pi. Historically, how they found pi is they took the circumference of a circle and they divided it by the diameter of the circle. And they did this with circles of all different sizes. They took circumference divided by diameter, and they noticed that no matter what size of circle they started with, if they divided these two things, they always got the same number. This 3.1415 thing over and over and over and over again. And that's how they originally discovered pi. Now what I would like to do is take this equation and rearrange it a little bit. So what I'm going to do is start off by getting rid of this denominator here. I don't really like denominators, so I have the circumference equals pi times the diameter. And you may remember that the diameter is the same thing as 2 radii. If you remember in a circle, here's my center, that's my radius, and then if you go all the way across 2 radius, that's the same thing as the diameter. So this is where we get that circumference equals 2 pi r. However, another thing we get if we divide both sides by r, we get, if we take the circumference divided by the radius, we get 2 pi, which, as a lot of you may remember, is how many radians are in a full circle. And this is why. The reason we have 2 pi radians in a full circle comes by the circumference of the circle. It's all related to that. So essentially, when we're talking about a radian, the reason it's called a radian measure is it's how many radius lengths would go around the full circle. So if I look at these two examples, right here, here's the radius of the circle. If I go around 1 radius, that's what I would call 1 radian around the circle. If I wanted to go 4 radians around the circle, then I would do 1, 2, 3, 4 radius lengths. And this goes for no matter what size the circle is. If the radius is very small or very big, it will still have the same number of radius lengths around the circle. So that's where we get this 2 pi, that if we kept doing this, we would end up getting about 6.28 radius lengths that go around the full circle. 1, 2, 3, 4, 5, 6, and a little bit left over. That's where 2 pi radians in the full circle comes from. Now, if all of that was really confusing, the basic thing you need to remember is that there are 2 pi radians in a full circle. So now we can think of this the same way as we did degrees. If a full circle is 2 pi radians, then half of a circle, half of a revolution, will be pi radians. Full circle is 2 pi, so half a circle is pi, which means a fourth of a circle would be pi halves radians. So we're going to come back here and we're going to do the same example we did before with graphing, classifying, and coterminal, but now we're going to do it with radians instead of degrees. So we are going to graph the angle in standard position. We are going to classify it according to what quadrant it's in, and we're going to find 3 coterminal angles, one of which is positive, one of which is negative. So first step I'd like to do here is graphing. Because we're now measuring in radians, our graphing is going to be a little different because I don't want to list degrees around this graph. I want to list radians. So I'm going to do 0 radians. Then I know this is a fourth of a revolution, which I just found out is the same thing as pi halves radians. This will be half of a revolution, so that will be pi radians. Then I go 3/4 of a revolution. That would be 3 pi halves radians. And all the way around is 2 pi. Now, when you're thinking about placing these angles where they go, I like to think of a ruler. So think of this as 1 inch, and then this is 2 inches. And then it's a little easier to visualize the fractions. So this would be a 1/2 inch, 1 inch, 1.5 inches, 2 inches. So then if I think of this pi 6 instead as a 1/6 of an inch, I know that a 1/6 of an inch is going to go between 0 inches and a 1/2 of an inch. So a 1/6 of an inch is very small. It'd be about right there. So that's where pi 6 would go. So then hopefully you can start to visualize this a little better. If I had 3 pi 4ths, where would 3/4 of an inch go? Well, that's more than half, but not quite 1 whole. So 3/4 of an inch would be about there. That would be 3 pi 4ths. So that's just a trick that I've used in the past to help me visualize where these radians go. I just think of rulers because it's a lot easier for me to think of fractions when I think of rulers. Anyway, now that I've graphed this, it's pretty easy to see this is a quadrant 1 angle. And now you can find coterminal. Now, big difference this time is our coterminal, instead of adding and subtracting 360, because that was a full circle in degrees, we're now going to be adding and subtracting 2 pi, because that is a full circle in radians. So I can add 2 pi to get a coterminal angle, or I can subtract 2 pi to get a coterminal angle. And honestly, you could probably just use your calculator for this. The easiest way to put this into your calculator is to ignore the pi's and then add the pi back on at the end. So here I would, in your calculator, do 1/6 plus 2, get a fraction, and then add pi to the end of it. This would be 1/6 minus 2, get a fraction, put pi onto the end of it. That's the easiest way to do it into your calculator, or you could also think of common denominators. So if this is in 1/6, I could times top and bottom by 6 to get 12/6. And then I have 1 pi plus 12 pi on top gives me 13 pi over my common denominator of 6. And then we could do the same thing here. 1 pi minus 12 pi gives me negative 11 pi 6. But I am honestly fine if you do it by hand or your calculator. Either's good with me. Now for my coterminal angles, I now have a positive one and a negative one, but I do need a third one. So I can take either one of these and keep adding and subtracting 2 pi to it. So I'm going to take 13 pi 6. And I'm going to add another full circle, add 2 pi. And if I do that, that's going to give me 25 pi 6. So those are all of my coterminal angles. They share the same terminal side as this angle, just going around the circle in different directions. So now that we've practiced finding one of those with radians instead of degrees, I would like you to pause the video and try the rest of them. Now remember over here with the negative ones, that just means it's the same measurements as this, but we go clockwise and they're going to be negative angles now. So pause the video, try out all 3 of these, and then come back and check your work. Welcome back. These are all the answers I got. Remember, you could have slightly different coterminal angles based on how you added or subtracted 2 pi. But all of your graphs should look the same, and all of your classification should be the same. So if you want to check your answers in more detail, go ahead and pause the video so you can do that right now. Otherwise, we are done with this video. In the last video for today's lesson, we're going to talk about converting between degrees and radians, how to go back and forth. I'll see you there.